Hey everyone, I thought I'd do another soldering tutorial. This time I'll cover kind of more in depth. It's mainly all going to be surface mount. So anyways, I have to do some rework on these, just basically flipping some components because they were backwards in the tapes when I mounted them. So they ended up being backwards. So we'll go ahead and rework those. And then I'm going to also change the microcontroller from this board, which is an older revision of my USB PH boards, and I'll go ahead and mount that onto the new revision. So it'll be kind of like how would you rework a bad board, and we'll take all these components, or most of them at least, and mount them onto here. The passives and all that I'm not going to even worry about. I got plenty of those, so mainly we'll just take the op amp, charge pump, and the microcontroller, and we'll go ahead and mount that on the new board. I'll kind of cover some of the tools and everything you need to do that. And I guess we'll kind of start off. Some of the very first things you'll need is some good tweezers. I kind of like these bent tweezers. They give you good angle, working angle on when you're picking stuff up. And that leads me into the second most important thing. When you're working with surface mount components, you definitely want a vacuum pickup tool of sorts. This is just a cheap one I got from the internet. It's the OIUE, or however the hell you say that, vacuum pickup tool. It was like $40. I had to put a transformer in line so it'll work with these smaller resistors. And I'll go ahead and move the camera here. That leads me to my secret weapon. Here are my boards that I sticky tape my passives and components down to. So this makes it really quick to mount a bunch of them, so you can have your vacuum pickup tool and do this. This is something I learned from Mike's Electric, and I'll go ahead and link his video up there, and you guys can watch that because he does a much better job at explaining things than I think I could ever do. But other than that, the vacuum pickup tool and the sticky tape and your passives and your components down on it, and it makes it really easy to do surface mount assembly. The other things you're going to need when you're doing that are a good soldering iron. Now I have a WX2 line here, which is for most people probably overkill. I do a lot of soldering, so it's kind of worth it to me. I especially use both ones depending on what I'm going to be doing. In this case, I have a gull wing tip for drag soldering and a just standard, I think it's a 1.8 millimeter chisel tip on this one. So those are my most common used. But when I'm doing heavy soldering, I'll put a more powerful iron on here, like 120 watt. These are both 60 watt pencils, and I find they work, for about 80% of everything I do. Occasionally I need a little more power, so I'll jump up to a 120 watt. They also have 200 watt pencils that you can attach to this. Tip care is very important when you got any kind of soldering iron. You want to take care of these. See if I can get this zoomed in a little bit better here. I always keep a blob of solder on this, and especially I like to keep the tin lead solder on here. If I can zoom in here, this is my favorite type of solder. It's the Kester type, so here's your model number. This is my favorite stuff. It solders very well. I mean, you can't really beat it, and it'll keep your tips lasting for years at a time. This tip I think is about 18 months old, and it's soldered tons and tons of stuff, and it still wets just fine. Having said that, I also use the brass sponges when I'm doing that kind of work. I don't use the wet sponges anymore because they will actually create microfractures in your tip, and it'll cause it to oxidize and degrade faster. Like I said, I've had these tips on here forever, and they're still good. I mean, I've considered changing them, and I have other tips. I got plenty of tips, but I'm kind of curious to see how long this will last before I need to throw it out. And the same thing on my gull wing tip. I always keep an ample amount of extra solder on there, and that just keeps it protected and you know, just in good shape, and it makes it really easy to do nice clean solder joints with it. Let's see, what else can I cover? So back to the soldering iron. I'll kind of move this stuff out of the way as I lose my pickup tip. Here it is. So a good iron. I'll link up links to some irons in different ranges. Basically, just get yourself a HowTo FX 888, and you can't go wrong with that. They make all sorts of tips for it, and like I said, don't waste your time with the fine tips. Just get yourself a chisel, couple chisel tips, and if you plan on doing a lot of Wick packaging or quad flat packs, get yourself a gull wing or a bevel tip will work just fine. I mean, I even drag solder with a chisel tip, so it's not a big deal. So yeah, a good iron with good tips, and that basically covers everything. For this iron, I might do a quick review a bit later, but it has a lot of options to keep your, you set your tip in here. These have accelerometers in here, so they know when you move it around. You can set it in your stand, and it, like 30 seconds or a minute later, you can have it ramp down in temperature. And then as soon as you pick it up, it'll be pretty much, by the time you get over to your workstation, it'll be up to working temperature. Even if you just turn it on, which you can see, it really does not take it long at all to get up to operating temperature. You can have different ranges, so I have when I really need extra heat, I just bump up the temperature on it. I usually just keep it around 650 Fahrenheit, so I mean, that's basically the gist of this iron. It's like any other. No need to spend too much time on it. But anyways, some of the other tools that are really important is Flux. So I'll go ahead and move my camera back over. Flux. You want to have lots and lots of flux. This is your friend whenever you're doing any kind of soldering. You want lots of flux. I use flux pens quite a bit, but when you're using these, you have to make sure you really clean your boards well. Why this says it's pH neutral, I've actually seen this stuff eat traces away, and it's caused a lot of heartache when you're trying to debug boards. In fact, I've had a couple boards. For example, this board right here had its power traces eaten away due to leftover flux residue. So it took me a while to finally figure out what was wrong with this, and I did of course fix it, but it's not even worth it really. And when I have this kind of problem, I don't ever really sell these boards, but I'm still always curious, and I like to find fixes for that kind of stuff. So anyways, like I said, good flux, and like these types of fluxes, it's kind of a no clean water soluble flux. It's not as harsh as these ones right here. This one you're going to want to definitely clean because it'll eat your traces. This one is gooey and nasty, but it can pretty much stay on your boards. Having said that, if you have a very sensitive op-amp circuit and you leave flux residue in between your pins, can it focus? If you leave flux residue in between your pins, you can come into situations where that's going to mess up your circuit, and you won't really know why. Let's go on to some more stuff. We've talked about fluxes and solder and irons, and the only other thing I really use quite a bit is a pan of ice or blue tack. So I'll take some blue tack, tack it down, tack my board down, then you can work with it without too many problems there. And that's especially useful when you're doing boards with components on two sides. So this one has components on two sides, and it can be kind of wobbly when you're trying to work on the other side. And so you can just tack it down and do your work and not worry about it. Let's get into some technique and actually start working with some of this stuff. I didn't talk about the hot air iron or the solder wick yet, so we'll get to that as we go. So right here we got some solder wick, which is your second best friend. You're going to want to use this to clean up any solder bridges, or when you're actually going to take components off the board, you want to take as much solder off before you pull it as possible. So I'll kind of demonstrate some of that right now, and we'll fire up my iron, clip off this stuff. So if we want to take this chip off, I'm just going to kind of heat it up, and you'll see, there we go, I can just kind of slide down and it'll just suck up all the solder on each pin. We'll turn it around and there we go. And then I just gently slide over all the pins until it sucks up all the solder. It really is best not to use any pressure when you're doing this, and just let the heat of the iron do all the work. That way you don't cause any damage or mess up the solder mask on the outlying parts, or areas, not the parts. So there. We'll just do this last side here. For some stuff this is kind of an unnecessary step, but it does also help just get all the extra solder off. So we kind of took all the extra solder off those pins, and now what I'll do is I'll tin my tip before I put it back. Now it's got nothing on it, so I'm going to tin it, clean it, and then tin it and put it back on the stand, and then I don't need to worry about it. Then what I'll do is I'll get my hot air iron here, right here, is my hot air. We'll flick that on, and I run these at about 270 C, 275, around there, so I don't melt plastic too easily. It does take a little while to heat stuff up, and then I usually run the air at about 1/3 of what its power is, so I don't blow components around. Then I'll just heat it up. See if I can get everything into view here. We'll heat it all up, and then once everything starts to melt, I'll grab onto the chip and pull it. So we'll just continue to heat everything up here, and let's see here. So we are going to grab a couple pins here. There it is. As you can see, it's now, well, we just kind of flipped it off. Okay, so I also want a couple more components, so I'm going to grab them right now. We'll grab my op amp. It'll release in just a second, and we want the charge pump. There we go. So once you get the board pretty much at the right temperature, it's really easy to take all this stuff off. In this case, you know, you could even pop this into the oven and just pull it off. And if you wanted to, you can actually pull off the USB connector as well. It basically is the same procedure. It will take a lot more heat though to get everything off. Just kind of spread all of my heat around here, and we'll keep testing it. There we go. And if there's anything else, you know, you could take your PTC here, take that off, and even LEDs if you wanted to, but that's all I'm going to take off for right now. Okay, since I got my hot air iron running still, I'm going to take this board, and the problem with this one is the op amps were actually mounted backwards. For some reason, a couple of them were backwards in the tapes. They weren't the same orientation. That occasionally happens, but I haven't seen it too much, and when I mounted all of these, they got mounted backwards. So when I tested them, they didn't work, and I quickly discovered the problem. We'll fix it real quick. So there you go. You can just pull that off. You can actually grab it, flip it around, and put it right back on. Now I'm going to go over and drag solder that to make sure we don't have any cold solder joints, but that fixes that one, and we'll just put this one over here and do the same thing. So I just keep heating everything until it releases, which should be any second now. It should pop off. And these hot air stations work really, really well, especially when you get the temperature and everything set perfect. You won't burn any of the plastic or put too much heat in everything, but it does have the trade-off is it takes just a little bit longer to get everything right. So yeah, okay. So I don't need to be perfect with those, since like I said, I'm going to fix them later and drag some of them. So there's all of our hot air work right there. So I can put that back, switch it off, and what we'll go ahead and do is we'll finish working these ones. I'll get my iron reheated, and here's where we're going to use the flux. So I'm going to go ahead and put a little bit of flux basically on each side here. Yeah, these are perfect. They're nice and warm. So, okay. Now I can just grab my iron, and it's already back up to temperature. And we can just basically just drag solder across all the pins. Looks like I might need a little bit more solder for those, but I think this will work. Yep, I do need a little bit more. It's kind of hard to watch through the camera and do it at the same time, but so what I can do is I can just put a little bit on there like that, and then just drag it across. Okay, same with this side. Just a little bit, don't need much, and you can just drag it across each pin. There we go. So now that one should work when we test it. That's been flipped, and we can do the same thing with here. Just a little bit of solder, and then drag it across. And as you can see, it might be hard to tell because I'm not very zoomed in. You'll see the solder kind of bridge and then flow to the next pin like that. So there we go. These ones should be fixed now. Now I'll re-tin my tip, clean it, and tin it again and put it into its stand. So the next thing we're going to want to do is mount the quad flat pack on here. So I'll just put a little bit of flux down, spread it around. It's actually kind of too much, but we'll clean it off. I'll cover that stage in just a second. And I'll heat up my gull wing tip. While that's heating up, we'll go ahead and grab this guy here, and we'll just pop him down and kind of get him close to place. We gotta get our gull wing tip, clean it here, so maybe you'll be able to see. As you can it's hard to tell, but I don't want to burn my hand. You can see there's like a little pocket in there. That's kind of how this works. So I fill the pocket up, and I'm going to want to stack the pins. We'll clean off my tip, and I'll fill it up quite a bit here. And then I'll take on one side, and then you just start at the first pin, heat it up, and then drag back down the pins. When you first start out, you want to spend a little bit of time until you get the feel for how long it takes. Sometimes they don't flow quite right, and it takes a little bit to do it. You don't want to spend too much time on a single pin so you don't burn up the bondings inside the chip, but you don't want to go too fast or else you'll have a cold solder. So there. So those ones are probably pretty good. I haven't really looked at them in close, but I'll fill up my tip again, and then we'll simply start at the first pin and drag back just like that. And same thing here. Fill up the tip, start at the first pin, and drag back. I usually put the iron at a little bit of an angle, and I'll kind of rest it on the very edge of the pin, and that allows it to get a nice heel on the front edge but still get the heat into the pan and up. So the next thing to check is if there's any bridges, and I don't see any bridges on there, so I can't show you how to fix that, but I do see that these are not. There we go. See, if it looks dull, then that means you don't have a good joint there, so you can just really quickly visually inspect these and tell if it's not a good joint. If it looks dull, then it's probably not a good solder joint. So then just go over it real quick. Sorry about the hand there. Just go over it and that'll fix it up. So I'm kind of done with this for now. I don't want to put it in just like this. With this kind of tip, I want to make sure I clean off all of the gunk and oxidation, and then I'll fill it up with a lot of solder pretty much all the way around the tip before I put it back into the stand. Then I'll take some Kim wipes like this and a bristle brush, and let me zoom back out here, and the little pump bucket. We'll get our brush nicely wet, and then we'll rest the Kim wipe over it, and we're going to clean off all the excess solder and flux, not solder, flux residue that was left behind. I'll go to a different part of this and do a final kind of cleaning there, like that. And as you can see, once that kind of dries off, we can get a fresh Kim wipe here and clean that off. There is no flux residue left over there. And I'll try and get us zoomed in better, but it's nice and shiny on all the pins, and there are no bridges. Now what happens if there's a bridge on there? Well, I'm going to go ahead and make one. I'm just going to flood one side here. We'll just pick this side right here. Get my iron better here. And I'm just going to kind of flood this out. There. So we got this big honking solder bridge right there. So how do you fix that? Well, there's a couple ways. This one has too much solder on there, but if it didn't, you could spread it around the other pins, but that's too much. So what we'll do is we'll take our solder wick, we'll put it down, and we'll just simply wick it away and spread it to the side. Once it's gone, you can then drag whatever excess is around, and as you can see, it just flowed right back up into the place there. So that's how you get rid of bridge. There's still a little bit on there. I'll clean my iron. I'll get just a little bit of flux on there, just a little bit. Don't need much at all. I'm just using a standard chisel tip here, and we'll just drag it throughout all the pads there, and there's no bridge anymore. Remember, I'll tin it, clean it, and put it back on the stand. That's how you take care of your tips. Always. Every time. So now, you can maybe see the off-color flux in it right here. That's what we pulled up by having the wipe in between when we clean it. So we're going to do the same thing again since we fluxed it. I'm going to get my brush wet and scrub everywhere around. And then you can go to a different part of the wipe and then do a final clean. So there we go. It's hard to see, but there's no bridges there now. So we cleaned everything. And there are, in fact, no bridges. Even though on that one it looks like it. There's nothing there. So that's how you fix a bridge. So, I mean, it's really easy to do. I could show you again. It's not a big deal how to fix that. Like I said, I mean, you just do a quick visual inspection. If they're all shiny, then chances are you've got a very good solder joint on those. Especially when you're drag soldering. It's almost like doing reflow, the way it flows onto the pins. So we'll leave that there. Actually, there is one pin that did not take. That's why it looks weird. It actually, there we just need to heat the pad. I bet that's a ground. Or no, it can't be a ground. It's one of the RX. Okay. It's hard to tell. I'm just going to go ahead and flow a little bit onto it. And see, that's why you don't need a fine tip. It's just a waste of time. You don't get good heat on there. I used to solder fitty chips with a fine point tip, and it was a pain in the butt, so I don't do it anymore. Go ahead and clean the flux off of that. And there we go. Okay, so I mean, you can apply the same principle. We can just mount this guy right on there. I'll put a little bit of flux down, put some on. Ooh, that's too much. Not a big deal though. It's kind of warm in here today, so this stuff is really flowing. Just slap it down. There we go. I got flux on my finger, so it's sticking to it. Get my gull wing tip again. Let's see, I've cleaned it off. Fill it up, and I'll just drag across the pins. There is one bridge. There we go. Trying to get it so you can kind of see it better. So I just drag across all the pins, and then if there's a bridge, I'll just drag it around until the solder kind of equalizes. With drag soldering, basically you're relying on the surface tension of the solder to do the work for you. And so you don't need to worry too much about how much solder you're going to put down on each pin. The pocket of solder makes a little rolling ball over the pin, so only a certain amount can get out at a time. And that's why you don't end up with a bunch of bridges, especially depending on how much you put into there. You can't really fill this up too much. And you can, but it's not a big deal. Then I'll switch over to my chisel tip so I can put a lot of heat into these pads here, and we'll just that was kind of a missed shot there. Just heat them up and let the heat do the work. You don't want to press hard with this kind of stuff, and you don't want to hold it on too long. You just kind of want to get it hot enough so the heat will flow the solder to all parts, the pad and the USB connector. So there we go, there's that. And you know, you can see the flux all flowing out. So what we want to do is we're going to want to clean that very well, and I'll show you how we do that. Kind of a final step here. I'll bring my camera up just a little bit. Here we go. Pardon me for a second. I have this nifty, this is a 50-50 mix of acetone and rubbing alcohol. Some people use methanol. Depending on what kind of components you're on, you want to choose that. I've heard the methanol cleans a lot better, but I use the alcohol and I don't have to worry about the plastics too much. And I'll just scrub everything down as well as I can. Depending on what kind of components you're mounting, you may or may not be able to do this. If you have a type of sensor that is water sensitive, you know, like a non-condensing hygrometer, you can't do this with it. You cannot clean it with this. In fact, you might sometimes have to seal them before you do cleaning, depending on your application. But for most of my stuff, I can just do submerging cleaning, and it works really well. Pull it out, dry it off here, and if this was a new board with all the components mounted on it, it's basically, so here's our board. I'll kind of zoom down as best as I can on it. Hopefully you can see it's all nice and clean and shiny, and we have all these difficult pads soldered very easy. There are some tricks with the other parts too. I wanted to show some passive component tricks. I have quite a few. You know, usually when I'm soldering, I will just use my iron and my solder as kind of my holder. But I've been doing this a really long time, so it kind of takes practice to do that. We'll mount the PTC. It's too much. Too much. Too much. Too much. Too much. It's okay. So we grab our PTC and I put it into place, and I grab my iron, clean it, and there's a little bit of solder onto it. You'll see it there, it just flowed. So I'll hold it right there, perfect placement. Turn it around, put it on, just a little bit, not much, done. That's all you need to do with those kind of components. You don't need to go through a whole lot of hassle of placing them and holding them with tweezers. If you have like a 10K resistor here, I don't know if I have any, I'll just mount something else out. Try and keep this under 40 minutes here. I'll just mount whatever I can on there just to show a little trick there with these things. There's a little bit of goo on my tweezers, it's okay though. So there, we've placed it in. Now this is a cool little trick using kind of the reflow properties of how these surface mount components act. So I'll put heat on there and a little bit of solder on the ground pad here, and if you get it just right, kind of hard to show, there it is. So you just got to pull away just quick enough and it'll sit in the right spot, and you don't need to hold it or anything like that, and then that's a perfectly placed component. So I'm not using a fine tip at all. I'm using a standard chisel tip with this. I've only used 2 tips for this whole thing, and if you really wanted to, you could use this chisel tip for everything to mount on this, including these LEDs here, the 50-50 LED, or the crystal and its capacitors. I just use the same method when I'm hand mounting them. It doesn't change at all. It's very easy to do. In fact, once you get used to this, I think most people that switch over from through-hole will find that this is actually a lot easier to work with. You can sit here and pull passes off and change them out and test them on the board really easy. And that comes in handy when you're doing, you know, here's a finished, this is one of my electroconductivity ones. Going from the breadboard to the final PCB, due to the ground plane and the change in the reactance of the basically of the traces and everything, I had to adjust the components ever so slightly to get my oscillation just right. So that's kind of a lesson there of the differences between through-hole components and surface mount components when you're moving from a breadboard to a PCB. But that's a different video entirely, and I hope you found these little tips and tricks for doing surface mount soldering helpful. So I will link to some other videos, especially Mike's video on the component placement. That's an awesome video. And I will link to some soldering equipment here, like there you go, you can see the vacuum pickup tool and my hot air station. And yeah, I mean, that's basically it. Get yourself a nice iron with a good tip, flux, lots of flux, good solder, some solder paste if you intend to do it, and some cleanup tools, and it's really easy to work with these types of components. I'll link to those other channels, and if you found this video helpful, go ahead and give me a thumbs up and share it, or leave some comments. It'll really help my channel out, and thank you. Bye.